All right, so we're on day 4 of Advent of Code, and we've got another pretty straightforward problem today, where basically every line is giving us two different elves, and they're cleaning. They're assigned to clean different sections of the beach. So we have all these ranges, and these ranges are all contiguous. So one elf will clean 2 through 4, another will clean 6 through 8, and so they're all paired up like this. In the first part of the problem, we just have to count the number of ranges here that where one of them is fully contained within the other. So this one where it's 6 to 6 is fully contained within 4 to 6. This one where we have 3 to 7 is fully contained within 2 to 8. So for this set of 6 examples, the answer is just 2. For part 2 of the problem, we're going to do the same thing, except we're also going to accept partial overlaps. So that would include, for example, 5 through 7 partially overlaps 7 through 9, and so on. So I'm going to do something a little different from the last couple days, where I'm basically going to recode this. I've already gone through it and gotten my answer correct, so we can already sort of see what I've got on GitHub down here. But I've written some unit tests for this. Everything's coming up as undefined now because I've stubbed out all these functions, and I'm just going to try to rewrite this from memory. It's a pretty short solution, so hopefully I'm able to do it. But obviously we have to start with our parsing. So once again, we're just parsing line by line. So each individual line just has 4 ints in these 2 pairs like so. And so we are going to want to parse a line by doing this. We want to use a helpful parser called parse positive number. That's actually in our utils file highlighted right here. We just get some digit characters, very easy. So we'll say A1, and then I think we then get the dash character, so we'll say A2, and then there's a comma, and then we go through this process again, except with B, and then we return A1, A2, B1, B2. Very simple. So what do we do with these pairs? So we have our easy part and our hard part. So both of these are basically going to be very similar. The only thing that's different is we have these 2 different conditions. So range is fully contained. This takes one of our ranges, so one of these integer pairs. In fact, I can just actually say line type and returns bool. And so we have A1, A2, B1, B2. And so this is pretty easy, right? So we have, in fact, we don't need the if statements because we're just saying, okay, A1 is less than or equal to B1, and A2 is greater than or equal to B2. In that case, we have B is fully contained within A. That's one case. The other case is we just invert everything. So we say A1 is greater than or equal to B1, and A2 is less than or equal to B2. In this case, A is fully contained within B. So how do we actually get our easy solution? We're going to do a fold. So our folding function is going to look like this. We'll have fold easy. So we'll take an integer and one of our lines, and it will return an integer. Still gonna hold myself to using a monad logger, even though I'm not going to need to log anything here. Just doing that as a matter of discipline. But so we have our previous score, our previous count of the items where this overlap occurred, and then we have our range. And so we're gonna say if range is fully contained, range, then return previous plus 1, else return previous. And so to actually process this input, very easy, fold m on fold easy with 0 as our input. And then we just take our list, and so that's all we really need to do there. And process input is going to be basically identical, just with one change in the condition, so it'll be fold hard with 0. We're just skipping that function, doesn't matter. Fold part 2, or I guess I kept this type signature, fold part 2. Same basic type signature, and it's going to say if range is partially contained. Then same thing, same deal. return 3 plus 1. Now we need to define this function, of course, but this function is going to be very, very similar. So partially, and our condition is a bit different. So we have to first say, okay, if a1 is less than or equal to b1. So there are two different cases. In this case, so if the left side of A is in front of the left side of B, then we just need to look at the comparison between B1 and A2. So we will say, for example, if B1 is less than or equal to A2, it's partially contained. We don't even need to do anything because that's the Boolean we're returning. Otherwise, so in the other case, we have B1 is actually strictly less than A1. So again, now we're comparing A1 and B2. So we will simply return A1 is less than or equal to B2. I'm going to take a moment and just think about the edge cases here, especially with regard to A1 and B1 being the same. I think there's actually an edge case. I might have actually missed this in my write-up, but if A1 and B1 are the same, we're dropping into this case. Oh wait, no, that's definitely gonna work. What am I thinking? Of course, that case is gonna work, assuming we've defined our intervals correctly. But I think we have here. So let's just go ahead and run this function through our unit tests. This might just work on the spot. I may have missed something, but something's still undefined. Oh, I'm calling the wrong function. Oh, whoops! I forgot to complete the parser. My bad. Step n by 1 parse line EOL. That's the pattern we always use when we're parsing something line by line. Don't forget to complete your parser, and all of our test cases pass. So once again, pretty easy solution. So in a few days, things will start getting more difficult though, so there will be some longer videos on the horizon, I'm sure. So stay tuned for that. If you want to stay up to date with all the latest news on Monday Morning Haskell, make sure to subscribe to our mailing list. That is, the link for that is in the video description below, and also just subscribe to our YouTube channel as well. So we'll see you in the next video.